tool that we're going to use more and more. Now we can even click this circle here and we can even create more accounts and give it a different account name. We'll call it account 2. This one has a different address. So if we go ahead, go back to Etherscan and look this up, this one has a different address here. So we can have multiple addresses in here. And now if I click this, I have 2 accounts, account 1 and account 2. The mnemonic that we've been given gives us access to create multiple accounts with that same mnemonic. So having that mnemonic will give us access to every single account that's ever created with that mnemonic. This is why securing your mnemonic is so crucial, especially if you create multiple different accounts. Now each account has a unique identifier with them as well. So this right here is the public address. When we copy this, this is the public address of that account. However, there's also a private key to work with this account, a secret key. And we can go ahead and view it by clicking these 3 dots, go to account details and export private key. Put our password in and confirm. So this is going to be our private key. So this is a single password associated with this account. If you give somebody else access to this private key, they will have access to my account 2. They won't have access to my account 1 because the private key of account 2 is only associated with account 2. The mnemonic, however, is associated with all accounts. And this is why when people say store your private keys in a safe place or store your keys in a safe place, they're usually referring to both your mnemonic and your private keys. If you lose your private key, you lose access to this account. If you lose your mnemonic, you lose access to all your accounts. So long story short, back up your mnemonic since it has access to everything, and back up your private keys too, but just keep in mind they only have access to the individual accounts. And great, those are some of the main security pieces here. Now, what else is going on in MetaMask is we can see this section here that says Ethereum mainnet. If we click it, we actually see a bunch of other networks in here. So when you buy ETH and when you work with ETH, you're working on the Ethereum mainnet. When you interact with smart contracts or DeFi or any things that we're going to talk about later on mainnet with real value, you're going to be working on the mainnet. However, since we're engineers, oftentimes we're going to want to test our applications or do some type of integration tests or just make sure our code actually works. So there's also what's called testnets. These are networks that resemble Ethereum and work exactly the same way as Ethereum does. However, they're not with real money and it's just for testing your applications. So we can even go to Etherscan and look up Rinkeby Etherscan. We can see the Rinkeby Testnet Explorer. We look up at our address and it's the exact same information here. Nothing has gone on Rinkeby, and this is totally different. So when we make a transaction, these are all different networks. And if it says test network, it's made to be made without real money. Later on, we're actually going to show you how to work with other EVM compatible chains. Don't worry about what EVM compatible means for now, but we can work with Avalanche, Polygon, and other applications through this networks interface as well. So remember, a testnet blockchain is a blockchain where the currency doesn't have any real value, but it resembles and acts exactly like the Ethereum mainnet so we can test our applications. So we can test and practice our applications. In fact, what we're going to do right now is make our first transaction on the Rinkeby testnet. And this will simulate exactly what it's like to make a transaction on the Ethereum mainnet. So we're going to go to this application called the Rinkeby faucet. This is where we're going to make our first transaction. Rinkeby is going to be one of 2 testnets that we're actually going to work with. The other testnet that we're going to work with is going to be Coven. It's important to know how to switch between testnets and EVM compatible chains, which is why we're going to be working with both. For now, we're just going to be working with Rinkeby. A faucet is a testnet application that gives us free test Ethereum. Hence why it has no value, because anybody can get it for free from one of these faucets. So to get testnet Ethereum with this application, we actually have to post a tweet or a Facebook post with this tweet. So I'm going to sign in real quick. And now that I'm signed in, I can post this tweet requesting faucet funds into, and this is where I'm going to put my address on the Rinkeby Ethereum test network. I'm going to go ahead and tweet that out. Now that I have this, we're going to copy, link to tweet, and we're going to place it in here, and we're going to hit give me ether. And we're going to say 18.75 ether for 3 days. And it said funding request accepted for Patrick Alpha C into this. And what we can do then is if we take this address again, we go over to Rinkeby Etherscan, we now see that the balance is 18.75. And we can even see that in our wallet. On the Rinkeby network, we have 18.75 ETH. But again, if we look at mainnet, we have nothing there. If we look at Robson, we have nothing there. If we look at Rinkeby, we have 18.75, right? So these are very different networks. And we've just made our first transaction. We've been given 18.75 ETH. And if we refresh this page, we also see that this is our first transaction that was made. Some account sent us 18.75 Ether from this account to us. And we can actually even look at the details of this transaction. Etherscan is what's known as a block explorer. Block explorers are applications that allow us to see details of things that happen on a blockchain easily. We can see the transaction details of this transaction here. And whenever we work with smart contracts, we will also see them in a transaction similar to what we're seeing right here. And again, we'll talk about that soon. Now we can see a number of information here. We see a unique transaction hash. This hash, or this unique identifier, uniquely identifies this transaction as the key of what this transaction is. We see that it was a successful transaction. This is the block number, which we'll talk about in a little bit. We see it was from this unique account, which looks like they've done a ton of transactions because this is the faucet account, to our account that we created. Value was 18.75 Ether. And then we have these transaction fees, gas price, gas limit, and gas used. Now, gas refers to the fee paid to node operators for successfully including a transaction in a blockchain. Now, exactly how this works is actually going to change pretty soon, but the concept is basically anytime you want to change the state of blockchain, whether this is sending some Ethereum or making any type of transaction, you actually have to pay a little bit of Ethereum or a little bit of that native blockchain token to actually execute that transaction. Whenever we do something on the blockchain, it costs gas. And if we do something that would take a lot of energy for the blockchain to do, it will cost more gas. So if I send a single transaction, that's going to cost 21,000 gas. However, if I were to send a transaction that called a smart contract function and did a whole bunch of other stuff, it would cost more gas. So we see here, when we got sent 18.75 ETH, whoever sent us that ETH also paid the blockchain miners or the blockchain validators a little bit of Ethereum to include our transaction. Now, we actually get to pick how much of a fee we want to send with our transactions. So let's look at another example. So in our accounts in MetaMask, let's even expand the view here. We have two different accounts. We have account 1 and account 2. Account 1 has 18.75. Account 2 has 0. We can actually send money from account 1 to account 2. And again, remember, this is all fake money. So we're going to go ahead and hit transfer between my accounts. So we're going to send money to account 2. And here's where we can see some transaction details. And we see the asset that we're going to send, which we only have Ethereum in this wallet. So we're only going to send Ethereum. Later on, we'll learn how to get different assets into this wallet. We're going to choose an amount. I'm just going to choose to send 1. And then we have these pieces here associated with the transaction fee. So we have a gas price in Gwei and a gas limit. So when we send a transaction, we can choose a gas limit. We can say, hey, if this transaction is going to spend more gas than 21,000 gas, we're not going to do it. We also get to set a gas price in Gwei, but here's the quick example of Gwei versus Ethereum. 1 Ether is this many Gwei, and 1 Gwei is this much Ether. Because if we just said, hey, could you send me 0.0000001 Ether, that would be kind of really obnoxious. So we just say, send me 1 Wei or send me 1 Gwei. So I know we've been throwing this gas term around for a little bit, but here is it basically simplified. Gas is going to be the measurement of how much computation something uses. The gas price is going to be how much it costs per unit of gas. A gas limit is going to be the maximum amount of gas that can be used in a transaction. So for example, if we make a transaction that uses 21,000 gas, and each one gas is 1 gwei in price, that means we're going to pay 21,000 gwei in transaction fee. So back in our transaction, we're saying the gas price is going to be 1 gwei. So the transaction fee is going to be the gas that we use, which will be up to this gas amount, times the gas price. So it'll be 21,000 gwei will be the transaction fee. So then the question is, well, why would we ever bump it up? Why would we want to pay more gas price? Why do I even have the option to pay more? Well, and this comes down to block space. We'll talk about this a little bit more when we get into how the blockchain actually works, but the blockchain can only process so many transactions at a time, and nodes and blockchain nodes can only process so many at a time. So when I make a transaction, a node has to decide why they want to include my transaction into the block. And if there are a ton of people looking to make these transactions, then the nodes are going to be highly incentivized to pick the transactions that are going to give them a high price, that are going to give them a lot of money for including that transaction. So this is what's called ETH gas station, and it is a gas estimator of the blockchain. It currently says that if you want to get your transaction in right away, it's going to cost you 31 gwei to do so. If you want to get it in less than 5 minutes, it's going to take you maybe about 21 gwei. So the gas prices of Ethereum fluctuate with how much people use it. And the gas prices of all these blockchains fluctuate with how much people use it. So this is an important concept. So typically when you're setting your gas price in a transaction, you can take a look-see at each gas station and say, okay, if I want mine to go in right away, I'm going to do ASAP. If I want to go in fast, maybe I'll do this fast amount. Standard, I'll do this standard amount. But it all depends on how many people are looking to work with this blockchain at the same time. And as you can see, it fluctuates pretty quickly, right? It just went all the way up to 46. So maybe more people are using the blockchain. Now, this is obviously for the ETH mainnet, and on the testnet, there's not going to be that same competition, but we can still change it anyway. So if I go ahead and do 100 for the gas price, and I hit next, and I hit confirm, if I go to activity, I now have this transaction in my MetaMask. But I can go ahead and view this on Etherscan as well. And we can see this is what it looks like when it's still processing this transaction. And now I can see that it's passed. And now if we look at the gas price, we see it's 100 gwei. And this is what we set it as when we were working with it before. So gas price is 100 gwei here versus our first original transaction was just 1 gwei. And now if we look at our MetaMask, we can see that the funds have indeed been subtracted from this account and they have been added to this account. Now there's 1 ETH in this account. Awesome. And you can see the activity. There's 1 ETH in here. So again, the reason that these gas prices exist is because nodes can only put so many transactions into a block. So they're highly incentivized to input the transactions that are going to give them a higher fee. So in times when a lot of people are looking to use a blockchain, prices will get very high. And when very few people are using a blockchain, prices will be very low. This Etherscan tool is incredibly, incredibly powerful, and we'll be using it more and more as time goes on. Now, here's something that's incredibly exciting. With just this little bit of information, you now know how to interact with blockchains and interact with the Ethereum protocol. So if you don't want to learn how to code anything, you can go and you can start interacting with Ethereum and interacting with protocols with just this much information. However, I know most of you guys are here to learn how to code. So let's look under the hood of Ethereum and what is actually going on with these transactions and with these gas and with these blockchains and what's really going on. Let's learn all the fundamentals of a blockchain. Now, if you want to just go ahead and jump into the coding, go ahead and grab a timestamp from the description. However, learning exactly how the blockchain works is going to make you an incredibly powerful developer. So let's take a look at that first. So we're going to be going through this blockchain demo on this site right here. Now, the creator of the site has a fantastic video and a fantastic walkthrough, Blockchain 101. It is right on their site. So if you're looking for another explanation, definitely check out his video. It is absolutely fantastic. But the first thing that we really need to do in order to understand blockchain, in order to understand really anything and everything that's going on here, we first really need to understand this SHA-256 hash, or hashing just kind of in general. Let's first understand what a hash is. A hash is a unique fixed length string meant to identify any piece of data. They are created by putting some piece of data into a hash function. In this example, the hashing algorithm used is SHA-256. Now, Ethereum actually uses this right here for its hashing algorithm, which isn't quite